Hello. In this video, we're going to go ahead and talk about interval notation. Our objective for today is that students will identify the domain and range of graphs using interval notation. And this is kind of a new idea that we're going to talk about. Interval notation. For prior knowledge, in your notes, you have your prior knowledge. We're going to go ahead and bring back in inequalities. Now, today when we're talking about this and we're going to graph these inequalities, remember that the less than and greater than signs have an open dot, and that the less than or equal to or greater than or equal to signs have a closed dot. Now, if I want to go ahead and graph x is less than 5, well, the less than sign tells me I have an open dot, so I'm going to put an open dot at 5, and I want all the x values that are less than 5, so I go ahead and I graph all the values that are less than 5. For graphing x is greater than or equal to -2, my inequality is greater than or equal to, so I'm going to have a closed dot here at -2, and I want all the values that are greater than. So I go ahead and I draw my arrows this way. For today's lesson, instead of using open and closed dots, we will use parentheses and brackets to indicate exclusive and inclusive values, just like interval notation. Interval notation. The following compound inequality, 2 is less than or equal to x, which is less than 8, can be written in interval notation. And here I have the interval 2, 8. Notice here I have a bracket and here I have parentheses. There is a bracket when there is a less than or equal to or greater than or equal to. And there is a parentheses when there is a strictly less than or a strictly greater than sign. So for step 1, if I want to go ahead and write the compound inequality here, -3 is less than or equal to x, which is less than or equal to 16. I want to write this in interval notation. Well, anytime there is a less than or equal to, I'm going to use a bracket. So I have bracket -3, comma 16, and the inequality on the upper end is less than or equal to. So again, I use a bracket. Notice this is just saying that x lives between -3 and 16, and we include the values -3 and 16. Notice the brackets match up with the less than or equal to signs, and my values stay the same. Let's look at another example. Here, example 2, I want to write the compound inequality in interval notation. So my values are -10, comma, -5, and I match my brackets or parentheses to my inequalities. Here I have less than or equal to, so I use brackets. Here I have strictly less than, so I use parentheses. This is saying that x lives between -10 and -5 when we include the value of -10, while we exclude the value of -5. Now, if we want to go ahead and identify the domain on a graph using interval notation, we can tell graphically if we're going to use brackets or if we're going to use parentheses. So here for our first example in our notes, I have a closed dot. When we have a closed dot, we're including that value. So that would be a bracket. Here I have an open dot, and that is represented by as a parentheses. So therefore my interval notation would be 1, 5. I'm including the value of 1, so I use a bracket, and here I'm excluding the value of 5, so I use a parentheses. So in interval notation, that is 1, 5 with a bracket and a parenthesis. For our second example, notice I have an open dot here, so that's going to be a parenthesis. So parenthesis -3, comma, and notice that this value goes all the way to the right. It does not stop. It has an arrow going all the way to the right. And when this happens, we're going all the way out on a number line to the value of infinity. Now, infinity is an idea or concept that goes on forever, so we don't use brackets with those values. This is a parenthesis. So -3, comma, infinity. I use a parenthesis here because I have an open dot, and I use a parenthesis always when we talk about positive or negative infinity. For our third example, again, notice I have a closed dot here, so I'm going to use a bracket. I have an arrow going this way, so my value is going to -infinity. And with interval notation, we always write the lower bound value and then our upper bound value. So meaning, what's my lowest value here that I'm talking about, this domain? Well, it is -infinity, comma, to 2. And here's where I include my values. So I have -infinity, that's parentheses. And then I have a closed dot at 2, that is a bracket. If you were to flatten the line along the x-axis, the domain would be the real numbers greater than or equal to 3. So if I was to flatten this, push it down onto this x-axis, notice this value would come down onto 3, and I would have an arrow that would go out to infinity. And we're gonna use this idea when we're talking about domain and range from graphs right now. So in your notes, please fill in. We have the domain of a graph is the list of all of the x values that correspond to the points of a graph. Remember, domain, x values, domain, x values. The range on a graph is the list of all of the y values that correspond to the points of the graph. So the range is all of my y values. So when I talk about where a function exists or where a graph exists on a coordinate grid, we're going to be using these values to describe our range and these values to describe our domain. So for our first example, if we are going to talk about the domain of this graph, notice if I flatten this down to my x-axis, if I push this graph down to my x-axis, it starts here at -8 and it's a closed dot. I'm including that value. I'm including the -8. And kind of graphically what's going on here is if I push this down, I have a closed dot here, and then I have an arrow that goes this way, and you can see it already drawn out in green. So here my domain would be -8, comma, infinity. This arrow is going to go on forever this way. Okay? If I'm talking about the range, well, if I squish this, if I push it over to my y-axis, right, my y values, notice I have a closed dot here at 4. It should be in red. I have a closed dot here at 4, and my values go all the way down to -infinity. So remember, interval notation is the lower bound followed by the upper bound. Okay, so my lowest value here for the ranges is going to be -infinity. My graph exists from -infinity all the way up until this value at 4, -infinity to 4. So I have an infinity, so I use parentheses, and my 4 has a closed dot, so that's going to be a bracket. -infinity to 4 is my range. We'll look at a couple more examples here. Here, my domain, my graph, if I push it down to my x-axis, I'm here at 5, and my arrow goes all the way this way. So my domain is -infinity, comma, all the way up until 5. Looking at my domain here for my second example, if I squish this again to my x-axis, this goes up here to -6, and then my arrow continues this way. So my domain would be -6, my lower value, and I'm going to use a bracket there because it's a closed dot, and it goes all the way to infinity. For range for this function, if I push this guy all the way to the y-axis, remember range is y values, here I'm at 1, and my arrow would go all the way up. Right? If I squish this, if I compacted it, pushed it this way, and on this side I pushed it like this, I have an arrow that goes up. So here my range would be 1, close bracket, all the way to positive infinity, right? Doesn't positive infinity exist up here? All the way down here, if we kept going, it would be negative infinity. So my range is 1, comma, infinity. My range for this function, if I squish this here all the way to the y-axis, if I push it this way, my dot would be at -4, and the arrow would be angled down, like this. So here my range is negative infinity, right? My lower bound, negative infinity, exists down here, all the way up until my upper bound, which is -4. Okay, I have parentheses here because it's infinity, and I have a bracket here at -4. What we have just done in these two problems is accomplish our objective. We have identified the domain, which is here. We've identified the domain and the range of graphs using interval notation. And the brackets and the parentheses, this is interval notation.